Hello everyone. So in this video we will see how the Java program is executed. So before going to how the Java program is executed, we should know about the programming language levels. So there are three levels of programming language. First one is high level, second one is low level or middle level, and the third one is assembly level. So what is the high level language? So basically the most of the computer program which was written by a human is called as high level programming language. It means the high-level programming language is the language that programmers can easily understand. So it contains normal English words which human can understand easily. So if you consider Java, Python, these are all called as high-level programming languages. So high-level programming language is a friendly language. So it is easy to understand. High level. Now what is low level? Next, low level. So if you see our computer cannot understand this high level language. It means the computer cannot understand this basic English language. So and computer can understand only bit, zeros and ones. Okay, so computer can understand only zeros and ones. So the code or the language which was written using these zeros and ones is called as low level language, and it is used by the computer. So low level language, it contains ones and zeros. That is machine friendly language. It means computer can easily understand the zeros and the ones, but it is very tough to understand for the humans because we cannot read zeros and ones, right? So it's very tough to understand. Now next, other other than these two, there is one more called as assembly language, assembly level language. So this assembly level is like basically it's more than the low level and less than the high level. It is like a basic intermediate. It's not like high level, not it's like pure English. Not in English, and not in zeros and ones. It is like intermediate language. It contains basic symbols, numbers. It contains all these things. Okay. Now, okay. Now, whatever we write in Java is a high-level language. So, how we write Java? We'll write in basic English. So, it is a high-level language, and this computer cannot understand the high-level language. So, what we need to do? So, we need to convert this high-level language, Java, into a machine-level language. It's like ones and zeros. So for converting this high level to low level language, we will use compilers and interpreters. Okay, we will see what are these compilers and interpreters. Now, so compiler and interpreter are the software programs that convert a high level language into a machine level language. So machine level language is basically zeros and ones, binary form. Okay? Now here, if you see, we are saying compiler and interpreter both convert the high level language into machine level language. Now, sorry, what is the difference? So, what is the difference between this compiler and interpreter? Okay, now compiler. Compiler, what it will do? It will convert the high level to machine level, but compiler will convert this complete source code into machine code at once. It means whatever we write in code, that code completely it is converted into machine code at once. Okay, once. Now, a compiler converts complete source code into machine code. If you see example, C program is a high-level language. But when we compile the C program, it convert all the C code into a machine language at once. It's okay. That is compiler. But interpreter. So what is interpreter? The interpreter is also a program that translates the source code into machine language. But here, interpreter will not convert whole source code into machine language at once, but it will convert line by line. So that it will consider the source code and it will interpret line by line and convert into machine language. If you see example JavaScript. So JavaScript is a high level language, but JavaScript is not completely converted. So it executed line by line. Okay, so JavaScript it cannot be executed whole. So only line by line it will be interpreted and executed. That is the example. Now, other basic difference, I mean, it's not like a difference. Other basic feature of compiler is compiler can also convert a high level code to intermediate level. So we'll see what is that intermediate level. So I think it's clear about compiler and interpreter. Now, now we'll see how this compiler and interpreter is used in Java. Okay, so how Java code is executed based on this compiler and interpreter. Now, now we discussed like high level code will be converted into low level code. Okay, so whatever you write in programming language that will be converted into low level. But if we see Java, Java is not a single step conversion. It means it will not directly convert from high level to low level language. So Java has a two-step execution process. Okay. So what we'll do in these two steps? So in the first step, the whole Java code is converted into bytecode. Okay, and this bytecode also called as class files. This is in the first step. So in the first step, the whole code which is written in Java, it is converted into a bytecode. And in the second stage, the bytecode is converted into machine code. So machine code is ones and zeros, binary form. So it is like two step. First, the program is converted into bytecode, and next to execute that bytecode is converted into machine code. So here bytecode is called as an intermediate code. Okay, so it is basically like assembly language, but not an assembly language. Okay. Okay. So now here we saw like there are two stages. Now we will see how compiler and interpreter are integrated in these steps. Now compiler. So compiler. So what compiler will do in Java? So compiler will convert the whole source code into a bytecode. Okay. So the code which we wrote in Java is compiled with compiler and it will convert into a bytecode. So if you see in your example, room.java is a Java code, Java file. Now this Java file, when we compile this Java file, the whole Java file is converted into a room.class file. This room.class file is called is a output of the compiler. Okay. So this room.class file is also called as a bytecode. Now what interpreter will do? Now interpreter will take the input as a room.class file, I mean bytecode, and it will convert that into machine code. It's like binaries, ones and zeros, and executes line by line. Okay? This is interpreter. So this is the how this compiler and interpreter are used in the Java code or Java execution. So compiler it will convert the source code into bytecode and interpreter will convert this bytecode into machine code and execute in the computer. Now, so we have seen how compiler and interpreter are used. Now we'll see what are the steps, how Java is executed. So first what we will do, we'll write a code in Java. Next, we'll compile the Java code and generate bytecode. Okay, or it is also called as class file. Next, this interpreter will use dot class file as a input and converts that input into a machine code, and that machine code will be executed on the system. So if you see here in the picture, test.java is a Java file. This Java file is the input for Java compiler, and this Java compiler will generate text.class bytecode as the output, and this bytecode is passed to the JVM. So JVM JVM has internally interpreter, and using that interpreter, it will consider the bytecode and it will convert to machine code and execute in the system. So this is how high level of a how Java is executed. Okay. Now till now we have seen how Java is executed. Okay. Now what is platform independent? So platform independent is basically uh, so whatever we write the code that should be executed on any platform. It means if you write in the Windows, the same code should be executed on the Linux, Mac OS. Anything it should be executed. So that is called as a platform independent. So why Java is called as a platform independent? So basically Java is called a platform independent. So why Java is called platform independent? So we'll see. So when we execute Java, I mean, what happens when we write Java code? First, what we will do, we will compile the code, and next interpreter will execute the code. There are two processes, right? So first, what happens? The compiler will generate the class files, and these class files can be transferred to any platform. Okay, and transferred to any platform and can be executed. For example, I wrote a Java code in Windows and compiled in Windows. So the class files we generated after compiling in Windows, the same class files I can transfer to Linux or Mac OS and can execute in the uh, other platforms. So what happens in other platforms? When I pass these class files to other platforms, in that platform, uh, it should have the interpreter. So the only condition to execute these class files in other OS is the OS should contain the Java installed in it. So when I compile the when I compile the Java Windows and generate the class file, that class file is transferred to other OS or other platform, and in that platform, as already Java is installed, means interpreter is already available. I will pass this class file as input, and the interpreter will convert to bytecode and execute that. So here there is no dependency on platform or OS. So this is called as a platform independent. But if we consider the C language, if we consider a C language, when we compile the C language, .exe file is generated. That .exe file is a platform dependent one. It means the .exe file which was generated in Windows, we cannot transfer to Linux or Mac OS and execute. It will give you error. It won't execute. So the exe file which was generated in Windows should run only in Windows. So that is platform dependent. But here in Java, it is not like that. So when we compile and generate a class file, that class file can be transferred to any other OS and can be executed. So that's why Java is called as a platform independent. I think this is clear for you how Java is executed on high level and what is platform independent. So this is for today's video. So we'll meet in our next video. Okay? Thank you.